Humanity is at a crossroads. We need to rapidly change course from the current path of carbon-intensive and resource-depleting growth and pivot toward a sustainable future where people and nature can thrive. But we have a narrow window of time. Building a sustainable future will require transformative changes at a pace and scale never seen before. And AI is an essential tool for driving the scale and pace that's needed. I'm Amy Loers, Senior Global Director for Sustainability Science and Innovation at Microsoft. The era of AI is just beginning to unfold. There's a great deal of uncertainty ahead, but one thing is certain: AI will drive tremendous changes through the global economy. And I'm excited to take you through what these changes could mean for sustainability. Before we begin, I want to highlight that this course is not a comprehensive overview of either sustainability or AI. Rather, I will explain the opportunities and the challenges that lie at the intersection of AI and sustainability. In this course, you will learn several things. First, that AI is a critical tool for accelerating sustainability progress. Second, that AI is not a silver bullet, nor a guarantee for solving our climate and biodiversity crises. Finally, you will learn about what needs to happen to fully harness AI's capability for sustainability. I'm eager to share with you what I've learned about the opportunities of AI for advancing sustainability and what it will take for us to realize its full potential. Let's dive right in. AI might seem like magic at first glance, but it's really just a collection of powerful tools built by humans. These tools are capable of carrying out complex tasks that previously only humans could do. As you will learn in this course, AI tools, if used responsibly, can be tremendous accelerators for sustainability progress. Let me give you an example. AI can help to optimize supply chains for sustainability. By analyzing vast amounts of data, such as data about the sources of material, manufacturing processes, and logistics, it can identify the most environmentally friendly and socially responsible routes and methods. This enables companies to reduce their carbon footprint and minimize waste. But how does it all work? Well, AI tools carry out complex tasks by learning from data, often massive amounts of data. Here are three primary ways that machines can learn. First, there is what is known as supervised learning. This involves training an AI tool using data that has been labeled. Take the example of teaching a machine to categorize images of forests. You would do this by providing it with thousands of labeled images, some tagged as healthy forests, others labeled as degraded forests, and others perhaps as burned forests. The machine uses these labeled examples to learn the features that distinguish a burned forest from a degraded one or a healthy one. Once trained, this AI tool can then categorize forests in images that it has never seen before. Second, there is unsupervised learning. This is the process where AI tools learn to identify patterns and relationships in datasets without labels or any other explicit instructions. For example, consider building an AI tool to improve weather forecasting. You could do this by giving it large amounts of weather data, such as temperature, humidity, precipitation, and wind. The AI model can analyze all the different data and learns to identify patterns and trends. This ability to learn from data without specific labels or other guidance makes unsupervised learning particularly powerful for understanding and predicting complex systems, and for applications where labeling data is simply impractical. Finally, there is reinforcement learning, which is a method where AI tools learn through trial and error. receiving feedback in the form of rewards or penalties. For example, you might want to teach a machine to manage a building's energy system, reducing energy consumption while ensuring the comfort of the building's occupants. The AI system will begin by experimenting with various heating and cooling and lighting settings. Then it can learn to adjust based on feedback from data on energy use and occupant comfort. These three learning methods can be used to develop AI tools that can interpret data, make predictions and inform decisions, generate text and images, and continuously learn and improve over time. In the next video, let's look at how AI tools can help people and organizations develop and deploy sustainability solutions faster, better, and cheaper. So now that we know that AI is a collection of tools, an intelligent toolbox, if you will, I want to explain why this toolbox is so valuable in helping humanity overcome key bottlenecks that currently hinder sustainability progress. But before we go into these bottlenecks, let me share some context for the scale of the sustainability challenges that the world faces. Each passing year brings new record high temperatures, larger catastrophic wildfires, and more frequent devastating floods. In response, international agreements have set ambitious global sustainability targets. By mid-century, carbon dioxide emissions must reach net zero. And by 2030, the loss of biodiversity must be halted and reversed. The good news is that significant progress is actually being made toward these goals, but change is simply not happening fast enough. The scale and speed of changes that are needed to meet global sustainability goals is daunting. Consider a few examples, such as global renewable power generation, which must triple in less than a decade. And methane emissions from fossil fuel operations must be reduced by 75%. Over the next couple of decades, food production must increase by 50%, and we will need to develop 1,000 times more durable carbon removal capacity than exists today. Society's progress towards meeting these and other sustainability goals is hindered by three key bottlenecks. The first bottleneck is that the process of developing sustainability solutions is often both slow and expensive. Many solutions require the development of new products or materials that are less carbon intensive and ultimately have a net zero impact on carbon emissions. Traditional research methods often rely on empirical trial and error, which can be painstakingly slow and labor intensive. For example, the search for new materials for longer lasting, more efficient batteries can involve evaluating a vast number of possible chemical combinations, which can require years of laboratory time and resources. In contrast, AI can rapidly identify and predict the performance of millions of different chemical compounds and identify the most promising candidates for further testing in weeks rather than years. A second bottleneck is the sheer complexity of all the social, technical, and biological systems that need to be better understood and managed. These systems include things like electricity grids, food production systems, global supply chains, and the many diverse ecosystems we need to protect. All of these systems are increasingly complex and interconnected. This makes them virtually impossible to measure, predict, and optimize with traditional analytical methods. Consider supply chains, which have become so distributed and interconnected, such that most are not feasible to manage manually or even with conventional computational tools. But with AI tools, we can make sense of the complexity and provide insights needed to ensure that supply chains are resilient to climate hazards while optimizing logistics and reducing emissions. The third bottleneck to sustainability progress is the growing sustainability skills gap. LinkedIn recently highlighted this gap in its Global Green Skills Report. In 2023, the number of jobs that required at least one green skill grew almost twice as fast as the share of the workforce with any green skills. AI-powered learning platforms can help by providing personalized training to individuals, by analyzing a person's existing skills, identifying gaps, and recommending tailored learning paths. This can significantly accelerate the upskilling process, enabling more people to contribute to sustainability efforts. Similarly, AI can help to automate many tasks. This will allow the world's sustainability workforce to focus on higher-level tasks, such as strategy development and decision-making. AI has a critical role to play in overcoming all three of these bottlenecks. In the next few videos, I will take you through AI's game-changing capabilities and explain how important they are for overcoming these bottlenecks and accelerating global sustainability. Did you know that by 2030, the world will need over 90 times more battery capacity, a 25% reduction in the carbon intensity of steel, and 30 times more durable carbon removal capacity compared to where we were in 2020? These are just some of the profound challenges that can only be overcome with new sustainable materials, processes, and products. However, as I explained in the previous video, there's a problem. Current approaches for developing and deploying sustainability solutions can be painfully slow and costly. Consider, for example, the development of new materials, such as those that are low in carbon or ones that can absorb carbon. IBM Research has estimated that on average it takes roughly 10 years and $10 million to $100 million to discover just one new material with specific useful properties. Given the pace at which the world needs to transition to sustainability, this might seem discouraging. Except, AI tools are already making these types of discoveries faster and cheaper. They are helping researchers to collect and analyze massive data sets, generate and test hypotheses, design, optimize, and automate experiments, and discover new insights and theories. Let me give you two examples to show just how powerful these new approaches to scientific discovery can be for accelerating the deployment of sustainability solutions. First, consider the world's food systems, which are facing increasing risks from climate change, increasing demand from population growth, and demographic shifts. Meanwhile, the global agricultural food systems account for nearly a third of all greenhouse gas emissions. This poses an enormous challenge. By 2050, under less favorable climate conditions, global food production needs to be 50% greater than it is today, while at the same time, emissions reductions need to be cut to near zero. New varieties of crops will be a key part of meeting this challenge, but traditional breeding methods for improving crops are slow, usually taking 7 to 12 years to create new varieties. AI is being used to speed this process up. It is helping researchers discover more climate-resilient crops by analyzing large, complex data sets, finding genetic markers linked to beneficial traits, and simulating how plants will react to environmental stressors. Batteries provide another example. Batteries are essential for storing and delivering energy for solar, wind, and other sources of renewable energy. However, today's batteries require scarce and expensive materials, such as lithium. AI is being used to accelerate the discovery of new materials for batteries by enabling researchers to search through millions of potential candidates, predict their properties and performance, and identify the most promising ones for further testing and development. For example, researchers at the Pacific Northwest National Labs, in partnership with Microsoft, used AI tools to narrow down millions of potential new battery materials to a few handfuls of promising candidates in less than a week. A screening process that could have taken more than 20 years to carry out using traditional research methods. These examples only scratch the surface. From helping to find new catalysts that enable low-cost production of green hydrogen and low-carbon industrial materials, or even hasten the arrival of nuclear fusion, the possibilities are endless. Given the scale and pace of change that the world needs, AI's potential to transform scientific discovery is a game changer. Sustainability solutions often require managing complex systems like supply chains, electricity grids, and agricultural ecosystems. These systems are made up of many interconnected parts, where a seemingly minor change in one part can lead to a cascading consequences in other parts of the system that are often unpredictable using traditional tools. Making sense of complexity is one of the areas that AI tools can do masterfully. It can help us measure and predict changes, optimize systems in ways we just couldn't do before. These capabilities can help increase efficiencies, reduce waste, and enable a faster transition to a more sustainable world. Consider electricity grids, one of the most important components of a future net zero world. Traditional methods of grid management are based on the assumption that energy sources are large, centralized, and predictable. However, as the world shifts towards ever-increasing use of renewable energy, our electricity sources are becoming more decentralized and variable, and traditional methods of grid management are struggling to adapt. This is where AI can play a transformative role. AI can analyze weather and energy use patterns in real time, predict upcoming demand and supply of renewable power, and even control energy storage and distribution systems. These capabilities not only help to optimize electricity systems, but help to facilitate the integration of more renewable energy sources onto the grid. Biodiversity and ecosystems are another area where AI can transform the world's approach to sustainability. Companies are increasingly required to measure and report any material impacts they have on nature. Measuring biodiversity and ecosystem is a huge challenge that requires collecting, integrating, and analyzing data from multiple sources and across scales. Traditional methods are often labor-intensive, costly, and limited in scope and frequency. However, recent advances in AI and Earth observations offer new ways to measure and monitor biodiversity and ecosystems more easily and comprehensively. AI can enable the analysis of vast amounts of different types of data gathered from the field and satellites, and can detect patterns and trends that are invisible to traditional analytical techniques. Combining AI with advanced Earth observation technologies can create a continuous, high-resolution, science-based system for monitoring the health of Earth's ecosystems. AI is also helping transform the world's ability to better understand and adapt to climate changes. One way it is doing this is by providing better and earlier warnings of extreme weather. For example, AI is transforming subseasonal weather forecasting, which is the prediction of weather conditions weeks and months in advance. This timescale of forecasting can have important implications for agriculture, water management, disaster preparedness, and public health. But subseasonal forecasting is currently not reliable because it requires precise knowledge of many variables that are difficult to measure and model using traditional process-based models. AI can help overcome these challenges by integrating and analyzing data from multiple sources, such as satellites, weather stations, and climate models. It then allows us to see patterns that process-based models do not capture. AI can also help analysts better understand the sources of uncertainty and variability in subseasonal forecasts, providing actionable information for decision makers. In a world of increasingly interconnected systems, harnessing AI's ability to handle complexity will be critical for successfully transitioning to a sustainable world. As we strive to meet global sustainability goals, we face a significant challenge, a growing gap in sustainability skills. The world needs a workforce that can design, drive, and track progress towards our sustainability goals. But currently, there are simply not enough people with the required skills and know-how to deliver change at the pace the world needs. This is where AI can play a transformative role. AI can serve as a virtual assistant, providing specialized support that can enhance productivity. Generative AI can assist professionals by distilling vast amounts of information needed for sustainability work, empowering them to make more informed and impactful decisions. For example, AI is being used to create virtual assistants for farmers and agricultural advisors to help them stay up to date with the latest science and provide better advice to enable more efficient and productive agriculture. Similarly, organizations like the United Nations Environment Program are developing apps like Environment GPT to distill the vast literature on environmental science into actionable insights. The power of these sorts of domain-specific AI assistants has been clearly demonstrated by GitHub Copilot, which is used to help software developers write code. In one study, GitHub Copilot enabled developers to complete coding tasks in less than half the time taken by developers who didn't use this virtual assistant. The sustainability workforce, which is already limited in size, is forced to spend much of their time on repetitive, time-consuming manual tasks such as data management and reporting. AI can automate many of these tasks, dramatically improving the efficiency of workflows. This is not just about task efficiency, though. It's also about optimizing human potential in the sustainability sector. AI can help companies make more impactful decisions toward net zero goals. Traditional training modules often adopt a one-size-fits-all approach, overlooking individual strengths and weaknesses. AI-enabled individualized training can be a powerful tool to address the sustainability skills gap. It can analyze a person's existing skills, identify gaps, and recommend tailored learning paths. This can significantly accelerate the upskilling process, enabling more people to contribute to sustainability efforts. AI is emerging as both an enabler and force multiplier for the sustainability sector. By providing specialized assistance, optimizing workflows, and offering individualized training, AI is empowering the workforce to more efficiently and effectively address sustainability challenges. You've gotten a sense for how powerful AI tools can be in the fight against climate change and other sustainability challenges. Let's talk now about what it takes to build an AI tool. Like any tool, AI requires resources to build and use. Resources like energy and water. In this video, I'll explain how water is used in the building and running of AI models. And I will put this in perspective of global water challenges and the sustainability transition. And in the following video, I will dive into AI and energy. So let's turn to water. Did you know that nearly half of the world's population could be living in areas facing water scarcity as soon as 2030? That's what the United Nations has warned. Today, many places in the world already face severe water limitations, but these challenges are projected to get worse. Global water demand is expected to increase by 55% by 2050. Manufacturing is expected to see a 400% increase. Thermal power generation might need 140% more water, and domestic use could jump by 130%. The expansion of AI operations is also increasing water demand, but AI's direct consumption is small relative to global demand. And fortunately, AI tools can also help to tackle the growing water crisis. The building and operating of AI tools can lead to water use in two ways. First, water is often used for cooling data centers, which can get very hot. Have you ever noticed your laptop feeling warm after being on for a while? Imagine a building full of computer processors. They can generate a tremendous amount of heat. Cooling is essential to prevent servers from overheating, which can lead to equipment failures. The second way building and running AI models can lead to water use is indirectly, through the water consumed in electric power generation, especially if the power plants burn fossil fuels. Renewable sources like wind and solar use virtually no water. This means indirect water use is essentially an energy issue, which I will cover in the next video. Let's take a closer look at the role of water in keeping data centers cool. Many data centers rely on water-based cooling systems. However, there are a variety of innovative cooling solutions in use today that don't require large amounts of water. These include advanced air cooling, liquid immersion cooling, and phase change cooling. With continued advancements and broader adoption of these technologies, data centers will become less dependent on water. Currently, at a global or even national scale, the combined direct and indirect water consumption by data centers is relatively small. For example, data centers in the US are responsible for only about 0.15% of national water consumption. Roughly 3/4 of this is related to electricity generation. And as you will learn in the next video, AI currently drives only a small fraction of all data center energy use. However, locally, without proactive measures, data centers can add stress to some local water districts, particularly if they are already water stressed. In addition to shifting away from water-based cooling systems, to address these challenges, many companies are increasingly investing in what is known as water replenishment. Water replenishment refers to activities that reduce use, recharge aquifers, or improve water quality in local watersheds and communities. AI can help implement and scale water replenishment. Consider this. Across the U.S., households waste 3 billion cubic meters of water each year because of leaky pipes. This is about 30 times as much water as is estimated to be consumed by AI operations globally in a year. What if AI tools could be used to find and stop water leaks? Well, that is actually happening today. For example, Phytotech is a company that delivers AI-enabled leak detection and water management solutions, which are already reducing leakage in municipal water systems around the world. As water challenges around the world become more severe, what is becoming increasingly clear is that the AI toolbox can provide powerful tools for overcoming them, if there are incentives and investments made to direct them to address these challenges. In this video, I will explain how the building and running of AI models uses energy. This is a similar story to what you heard about water in the last video. The expansion of AI will likely have a relatively small impact on energy at a global scale, but can pose local energy challenges in some areas. Let's take a look at the energy demands of AI. Currently, data center and data transmission networks overall consume about 2% of global electricity. However, AI models consume only a fraction of this. AI is estimated to account for less than 1/10,000th of a global electricity use. Another way to put AI's electricity use in perspective is to compare it to other uses of electricity. For example, the electricity used when watching TV. Consider this. Currently, each day, ChatGPT responds to about 200 million requests from around the world, consuming about 600 megawatt hours of electricity. Although this may sound like a large number, it's equivalent to the electricity consumed in just 1 minute by people in the United States watching TV at home. Now, of course, as AI use expands, the energy needed to operate AI models will increase. The International Energy Agency projects that energy demand of AI-dedicated data centers could increase as much as tenfold by 2026. Much of the increase in energy use may be offset by increased efficiencies. Over the last decade, despite the explosive growth in computing, energy use by data centers and data transmission networks has remained relatively stable due to dramatic improvements in energy efficiency. For example, between 2010 and 2020, global data center workloads increased by 900%, yet electricity demand grew by only 10%. Moving forward, AI-related efficiency gains will likely continue by improving software design, building smaller models, and optimizing hardware. Now let me turn from the global perspective to the local perspective, where the energy story can be quite different. Locally, data center electricity demand can be large relative to supply, potentially putting pressure on local grids. This is because data centers have historically been concentrated in regions with favorable economic and regulatory environments. In these regions, data centers can use a significant portion of the local grid capacity. For example, data centers consume 17% of Ireland's electricity in 2022. Meeting the demand of new data centers to support AI and other cloud computing will require increasing local electricity generating capacity and modernizing local grids, particularly given that future growth in power generation must come from renewable sources. In this video, I explain that AI tools are not major consumers of electricity at a global scale. But if not managed properly, the rapid growth of AI could create significant pressures on local electricity grids where data centers are concentrated. Energy challenges posed from the growth of AI are primarily local challenges. In the next video, I will talk about a global issue, the implications of AI growth for greenhouse gas emissions. To understand the full carbon emissions implications of AI, it's necessary to consider both the direct and the indirect impacts of AI use on emissions. The direct impacts refer to the emissions that result from the building and operating of AI models. This is often referred to as the carbon footprint. The indirect impacts of AI refers to the reductions or increases in emissions that may result from how AI tools are used. Most assessments have focused on the direct impacts, which are easier to quantify. But as we will talk about in the next video, the indirect impacts, which can be both positive and negative, will likely be significantly larger than the direct impacts of AI operations. But let's turn first to the direct impacts. The direct emissions resulting from building and running AI models are determined by three factors. The first factor is the amount of electricity used to train and operate models. As I discussed in a previous video, AI models currently use a tiny fraction of the world's electricity. With the expansion of AI, electricity consumption will undoubtedly grow, although some of this growth will likely be offset by increases in efficiency. But electricity use only results in carbon emissions if the power is generated by burning carbon-rich energy, such as fossil fuels. So the second factor influencing direct emissions is the carbon intensity of the electricity used. That is, how much of the electricity use is from fossil fuels versus renewables or other zero carbon energy sources. The third factor is the greenhouse gas emissions associated with building the infrastructure for running the AI models. These are known as embodied emissions. A key determinant of direct emissions from expanding AI operations will be how rapidly the world's electricity grids shift to zero carbon energy sources, such as wind, solar, hydro, and geothermal. The rate of grid decarbonization will not only affect the amount of emissions from the electricity used for running AI models, but also the embodied emissions, which are largely due to energy consumed in assembling digital processors and building the structures to house them. Currently, the carbon intensity of electricity grids varies tremendously around the world. As a result, where data centers are located has a large influence on the emissions directly linked to AI services. For example, the average carbon intensity of the electricity grid in Australia is 17 times higher than Iceland's grid. Rates of decarbonization also vary by region. For example, in the last 5 years, the Netherlands reduced average grid carbon intensity by 31%, while India reduced average intensity by just 4%. To meet the world's sustainability target of net zero emissions by 2050, AI tools and the infrastructure that enables them must be designed and operated to minimize their direct emissions. Large companies providing AI services are already investing heavily in renewable power to supply or offset the power used by their data centers. Continued innovation will be needed to maximize efficiency, expand the supply of zero carbon energy, and modernize electricity grids. The good news is that AI can help accelerate those innovations. AI is already transforming the energy sector, transportation, health, finance, and so much more. As these transformations unfold, many will indirectly impact emissions. These indirect impacts can be both positive and negative, meaning they can lead to reductions in emissions and some could lead to emissions increases. Let me give you two examples where the use of AI tools can lead to indirect emissions reductions. First, AI is helping to increase the capacity of electricity grids and facilitating the integration of more renewable energy. AI is already being used by companies like Line Vision to increase capacity of electricity grids, and in some cases by up to 60%. Now consider another example, food waste, which is responsible for roughly 8% of global greenhouse gas emissions. The United Nations reported that in 2021, 13% of the global food supply was lost along the supply chain between farmers and consumers, and a further 17% was wasted by households, food services, and retailers. AI tools are already helping to reduce food waste by helping retailers dynamically price their fresh food to ensure that it is sold before it expires. This has reduced waste by over 30% in some cases. And these reductions in food waste indirectly lead to reductions in emissions. The potential of AI tools to reduce emissions could be huge, especially if it enables breakthroughs that accelerate the development of zero-carbon energy sources such as geothermal and nuclear fusion, or breakthroughs that lead to better ways to store energy. Breakthroughs like these are already starting to emerge, and they could be game changers for the world's sustainability journey. On the other hand, if AI is not governed properly, it could facilitate unsustainable consumption and resource extraction. In the next videos, I will explore alternative potential emission scenarios that could result from different ways AI tools are used and deployed. A couple of years ago, I was part of a team of international researchers who came together to explore how AI and digitalization more broadly could influence the future of greenhouse gas emissions. Together, we sketched out three possible scenarios. In the first scenario that we conceptualized, AI and other digital technologies would increase economic productivity, but also increase energy demand and resource consumption, leading to an increase in greenhouse gas emissions. This is obviously not a sustainable or desirable path. In the second scenario, AI and other digital technologies accelerate the deployment of renewable energy and increase efficiency while avoiding overconsumption, but with constrained human agency. This leads to a decrease in greenhouse gas emissions, but unsustainable social outcomes. In the third scenario, AI technologies are used efficiently and effectively with trusted governance, empowering people, and accelerating decarbonization. This is a sustainable path that AI can help the world achieve. To harness AI's potential for steering the world towards a truly sustainable path, deliberate efforts are required to create the necessary conditions for success. So let's wrap up by outlining the enabling conditions needed to succeed. Let me round out this course by walking you through the 5 key enabling conditions that are needed to unlock AI's full potential for sustainability. These were identified in collaboration with sustainability researchers and practitioners with many years of experience in the field. First, we need increased investment in AI for sustainability. This must include providing financial incentives, creating opportunities for AI research focused on sustainability, and fostering partnerships between AI and sustainability experts. Second, we need more development of inclusive digital and data infrastructure. For AI's promise in sustainability to be successful, it must be representative and inclusive. This requires investing in filling critical data gaps, particularly in underrepresented regions of the world. Data gaps are widespread across many sustainability issues. The UN Environment Program estimates that 58% of the environment-related indicators for the World Sustainable Development Goals lack sufficient data to monitor progress. In addition, AI-ready data standards need to be established and adopted to enable effective use of available environmental data. Third, we need to minimize resource use and prioritize renewable resources. As AI demand increases, minimizing the resource footprint of AI operations becomes essential. This requires sustained investments in data center efficiency and following best practices for resource utilization. Prioritizing zero-carbon energy sources in AI infrastructure and operations is essential for reducing environmental impact of building and running AI models. Fourth, we need to advance AI policy principles and governance. Establishing robust policy principles and governance structures for AI in sustainability is vital. Policies are needed to support the transition to carbon-free electricity grids and the integration of AI into existing sustainability frameworks. Effective governance must ensure that the use of AI in sustainability is safe, secure, and trustworthy. Fifth, we'll need to build capacity in the workforce to use AI for sustainability. Unlocking AI's potential for sustainability will rely on a workforce able to use AI tools. This means creating pathways for education and training that equip the sustainability workforce with the skills and knowledge to use AI effectively. Cultivating AI fluency within the sustainability context is crucial for leveraging AI in meaningful ways. With these 5 enabling conditions in place, AI can be the game changer we need to deploy sustainability solutions faster, cheaper, and better. As you move forward on your sustainability journey, I encourage you to learn more about how you can use AI to accelerate your sustainability efforts, how you could build AI skills for sustainability, and ask yourself, what can you or your organization do to help establish the broader enabling conditions that are needed for AI to help the world accelerate to sustainability? The window for transitioning the world to sustainability is narrowing. Fortunately, the growing AI toolbox presents an incredible opportunity to drive change at the scale and pace needed to achieve our global sustainability goals. But only if, as a society, we collectively focus on establishing the enabling conditions for success. Together, we can do this.